Okay guys, we're going to give this a shot. A couple of you said you would kind of like to try the videos if I ever had time to make them, so we're going to see how it goes. Today you're going to learn about these things called quadratics. Quadratics just means you have an x squared. That's it. You just have an x squared, so it's a quadratic. When you put it on the graph, it's going to be in the form of a u. Alright, now all these key concepts just says you're going to have a u. The u might open up, the u might open down, and it always has a line that folds it in half. This line is called the axis of symmetry. And either the bottom point or the top point is called the vertex. Sometimes it's a bottom point. When it's a bottom point, it's called a minimum. Sometimes it's a top point. If it's a top point, it's called a maximum. Okay, here's the long story short. You are going to have an x squared. This is called, fancy word, a quadratic. Quadratic. Because of this, the graph is going to be a u going up or a u going down. We call these parabolas. Kind of a funny word, parabolas. The top or the bottom point is called the vertex. And today I'm going to teach you how to do that. Problem 1. What is the vertex of the graph? Is it a min or a max? So they give us a picture. I'm going to label the vertex with a green dot. Notice it is at -1 and +4. So it's at a point, -1, 4. And since it's at the top, it is a maximum. Yeah, it's going to get harder, but that's it for now. Let's try problem 1 again, a different type. What are the coordinates of the vertex? Min or max? So the very tippy top point I see on this one is right here. It happens at 0, 3, over 0, up 3. And since it is a top point, it is a max because it is a top point. Last one. The vertex is right here. Got to get used to that word vertex. We're going to do it again tomorrow. And it happens at left 2, so -2, -3. Don't get your x and y's mixed up, okay? It always goes x then y. Because it is a bottom point, it would be a minimum. That easy on this one, okay? Let's try problem 2. Graph this function. So this time you're going to have to make the graph. What's the domain and the range? So they already told us to plug in -2 through +2. Tomorrow we'll plug in different points, but today, -2 through +2. So we take our calculator or our brains and we plug in -2. So everybody sees this -3, so I type -3 parenthesis, and I plug in for x. They want me to plug in -2, close my parenthesis and square it. I get -12. So -12 is what I get when I plug in -2. So the answer, or the point is -2, -12. Let's plug in -1. So I'm going to do -1 squared is 1 times -3 is -3. Again, you can use your calculator. Use parentheses, otherwise it will be wrong. So I get -3. Plug in 0. Well, whoops, wrong spot. I love plugging in 0 because 0 times anything is 0. So we get 0, 0. Plug in 1. So 1 squared is 1 times -3 is -3. And plug in, they want +2. +2 squared is 4. 4 times -3 is -12. Again, you can always use your calculator. Just make sure you use parentheses. All right, let's plot this thing. -2, -12 is left 2. 1, 2, 3, 4, 5, 6, 7. I lost count. 1, 2. Oh, we need 2 extra dots, so I'm going to be lazy. I'm just going to put it right there. -1, -3. Put that there. 0, 0. 1, -3. And 2, -12. All right, so I've got these 5 points, and you can see it's going to be an upside down parabola. So we're just going to graph going that way. Please make it look like a U. Try not to make it look like a V. Now, The domain means how far left and how far right does it go. Well, this is going to continue to spread out forever left and right. So we write domain are our x values, and for parabolas, x is all real numbers. That's what that weird looking R means. In other words, x can be anything. I can plug anything I want in for x, but the range is different. The range is up and down. So the range is the one that we got to be super careful about. Can you see how this one goes down forever? We say y is less than or equal to, well, where does it start? Right here at 0. So the range starts at 0 and it goes boom, down forever. So less than or equal to 0. The vertex is that top point right there, 0, 0. I know it didn't ask for it, but can you see that it's a maximum point because it's a top point? Let's try that again. Graph, fractions, boo. Graph y equals 1/2 x squared was the domain and the range of the function. Let's make an xy chart. Okay, so I am going to encourage you, since you have a denominator, instead of picking -2, -1, 0, 1, and 2, I'm going to suggest that you skip by 2s and do -4, -2, 0, 2, and 4. Now, if you want, I used multiples of my denominator. If you want to use -2, -1, 0, 1, and 2, you're not going to get it wrong. I'm just going to have a much prettier graph. Okay, and I won't have decimals like you're going to. So let's plug this in. So we're going to do 1/2 parenthesis, trying to get my left hand out of your way, -4 squared. Well, -4 squared is 16 times 1/2 is 8. If you struggle with that, 1/2 times -4 squared, that's how I get 8. Let's do 1/2 times -2 squared. Ready? I get +2. Oh, I love plugging in 0. By the way, tomorrow we'll get a little, the plugging in will get a little more challenging. All right, 1/2 +2 squared. I get 2. And now 4. I mean, you can do this in your head, but I always suggest double checking yourself. P.S. If you don't use, it's at 16, it's 8. If you don't use parentheses, you will get it wrong, especially at the negatives. All right, notice this beautiful reflection. Do you see it's 8, 2, 0, 2, 8? That's why we have that axis of symmetry, or that middle line that it folds around. Plot our points. -4, 8. 1, 2, 3. All right. Next point, -2, 2. 0, 0. 2, 2. And 4, 8. Do you see that beautiful U shape and it's perfectly reflected? That's exactly what you want to see. Make it look like a U. Do not make it look like a V. Okay? The domain, well, you see how it's going forever left and forever right? That means x is all real numbers. Do you see how this time it starts at 0 again? But this time it goes up from 0. So we're going to do y is greater than or equal to 0 because it's going up. What is the vertex? Well, 0, 0. Tomorrow the vertex will change, but today the vertex is 0, 0. And I know it doesn't ask for it, but you see how it's a bottom point? It is a minimum. Okay, now you're going to learn about wide versus narrow. It all deals with the number out front. Let's put in front of x squared. Okay, it does not deal with if it's positive or negative. Doesn't matter at all if it's positive or negative. Now let's talk about up and down. Up and down deals with the number out front. In front of x squared. Actually, you know what? Let's change this. It deals with the, how about we change this to say it deals with the sign in front of x squared. And it does matter this time if it's positive or negative. Okay? So up and down definitely deals with positive or negative. All right, let's check this out. Problem 3. We're going to put these from widest to narrowest. Okay, guys, in order to be wide, It has to be, oh, maybe I should have put that on, probably should have put this on this page, huh? Let's back up. Okay? I want to talk about wide. I should have put this here. Wide is if the number is less than 1. Okay? For example, if you have 1/3 x squared, or 1/2 x squared, or 0.2 x squared, those are wide. Okay? Narrow will be big numbers, like if you have a number greater than 1. For example, 4x squared, that's narrow. 2x squared, that's narrow. Even negative 5x squared is narrow because we don't care about negatives. Now we can go on. Problem 3. Put this in order from widest to narrowest. So you see how we have this little guy, this 1/3? He's the widest between 2 and 4. So wide is negative 1/3 x squared. Now, the 2 is the next smallest, so 2x squared. And the narrowest is the big 4. Try it again. Oh, there's a 1 here, right? So we just need to find like the smallest number out front. Well, that's going to be the 1/4. Don't worry that it's negative. It still makes it wide. And then, what do you think, the 3 or the 1? The 1. I don't care that it's negative. I just care that it's 1. And then the biggest number, 3x squared, means that it's the narrowest. Miss Shirey put all this in a nice little box for you. It says the coefficient tells you if it's pretty much what we just did. It tells you if it's wide. It's also going to tell you if it opens up and down. You can read through this, but this is what I call math language. We're going to just try to apply it on the next slide. Ready? Let's take a look at these two graphs. Oh, I think that should say -3. I don't know what happened there. Make an XY chart for both of them. Okay. And now we're going to plug in those magic points. I don't see any fractions, so we're going to plug in our magic numbers. That's how you're going to graph today. Plug in your magic numbers unless you see a fraction. Okay. -2 squared is 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. We can plot those points. That's going to be the most basic parabola you'll ever see. If I plot, by the way, if I start plotting things way too fast, just pause the video and catch up with me, okay? Alright, let's plug in the other one. Oh, it's going to be a little more difficult because we have to subtract 3 at the end. So -2 squared minus 3. Well, that's 4 minus 3, which makes 1. -1 squared minus 3. Well, that's 1 minus 3, so that makes -2. 0 squared minus 3 is -3. Boy, I made that nice and small for you, didn't I? 1 squared minus 3 is -2, and now we have our reflection. And 2 squared minus 3 is 4 minus 3, so it's just 1. Use your calculator if you need to. Plot those new points. -2, 1. -1, -2. 0, -3. 1, -2. 2, +1. And connect to make your parabola. I'll make this one in green since it's kind of like, it's not overlapping, but it's like really close to the other one. Try to make it look more like a U than a V. And this one says, how are these graphs related? Well, they're related by the second one goes down 3 units. Do you know why? Well, if you look at your equations, do you see the -3 in the back? That moves it down 3 units because of the -3 in the back. See this stuff right here? That's saying that the number in the back moves it up or down, which we just proved. So in number 4, it asks, how are these two graphs different? We'll see how this one has a +1 in the back. This one would just be 1 unit taller. That's it. So if the first graph looked like this, the second graph would be moved up a unit, and it would look like this. Same shape, it would just be moved up 1 unit. All right, can we flip backwards? Because that makes sense, right? Why don't you flip backwards? I didn't see a problem on here, but I would like to talk. Does everybody see that negative right there in this problem? I want you to know that this would be an upside down parabola because of the negative. Do you see how this one's positive? That would be a regular parabola because it's positive. This one's positive. It would also be a regular parabola because it's positive. See how this one's negative? It would be an upside down parabola because it's negative. See how that one's negative? It would also be an upside down parabola. See how this one's positive? It would be a normal parabola. I just want to make sure that I showed you that. All right. 2 more problems and we will be all done. Problem 5. An acorn. An acorn drops from a tree that's 70 feet above the ground. So here, if you need a picture, if you're a picture person, here's a beautiful tree. I'm a really good artist. Right? An acorn drops from a tree, whee, boom, and it hits the ground. Okay? And it's 70 feet when it starts. This is the equation. You don't know this, but negative 16 is actually the pull of gravity. So we have the pull of gravity pulling it down plus the 70 feet where it was at the beginning. T stands for time in seconds. And H will tell us how high the acorn is. So it says, what's the graph and when is it going to hit the ground? So at the very, very beginning, like right before it falls, when you plug in 0, time is 0, you plug in 0 and you get negative 16, 0 squared, plus 70. Well, I hope that makes sense that before it falls, it's up in the tree at 70 feet. Now we're going to plug in 1. So after 1 second, so negative 16, 1 squared, plus 70. Make sure you use parentheses and put them in the right spot. Ready? Negative 16, 1 squared, plus 70. Notice my use of parentheses. 54. So that acorn, after 1 second, has fallen from 70 to 54 feet. Plug in 2. Same deal. Ready? Negative 16 times 2 squared plus 70. You get 6. Wow. It really does. So that's the thing about things that fall. They start to fall really fast. So it was at 70 feet. Now it's down to 54 feet. Now it's down to 6 feet. At 3 seconds, I have an email. Let's plug in 3. Yikes, negative 74. Now, I am hoping that doesn't make any sense to you at all. How can something be negative 74? That would be like falling below the ground, wouldn't it? Yeah, so after 3, once we hit that negative, it doesn't make any sense. In other words, somewhere between here, it's going to hit the ground. Somewhere between 2 and 3, it's going to hit the ground because it goes from being at 6 feet in the air to being, what, like negative 74 feet in the air? That doesn't even make sense. Let's plot our points. So at 0, we're at 70. At 1, we are at 54. At 2, we're all the way down to 6. And at 3, we would be like down here at negative 74. So here's what we're going to do. We're going to plug in like, let's try, because it says, when does it hit the ground? Let's try 2.3. I'm just like taking a random guess, by the way. I don't even have the answer key by me. I just want to see what's going to happen at 2.3 seconds. Well, no, that's below the ground. All right, let's try 2.2. This is just me guessing. Let me be lazy. 2.2, ready? That's still negative, isn't it? Let's try 2.1. It's just a matter of guess and check right now. That's pretty good. So at 2.1, I get that it's at negative 0.56 feet, which, I mean, you can't really be negative. So here's what I'm going to say. I narrowed it down really, really well. 2 and 2.1 seconds, it hits the ground. Now, you might be like, well, what would be perfect? If you could get 0. If you can get 0, I mean, that would be exactly when it hits the ground. Maybe, do you want to write that somewhere? Where can we write that? When it hits 0, that would be 0 would be perfect because the ground is 0 feet tall. But you can see somewhere between 2 and 3 and super duper close to 2, it's going to hit the ground. Let's try this one more time, okay? Number 5, a child drops a pebble from a height of 30 feet above the lake. The function h equals yada, 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 gives the height of the pebble in feet. And you can see there's the beginning 30, there's the pull of gravity. What is the graph? When is it going to hit the water? So we are dropping, I'm not even going to try to draw this, but there would be a little kid dropping here you go. Here's the pebble. It's falling. Here's the river. Okay? Fancy. Let's go ahead and make an XY chart. Always start with 0 because that's when, before the kid throws it. So negative 16 times 0 squared plus 30, that's going to give you 30. Now, let's plug in 1 second. Oh, look, they even tell you what to plug in. Why don't we plug in what they have? So let's plug in 0.25. Now, I'm going to use my calculator here. I expect you to be able to use whatever calculator you have available to you. No excuses if you don't have a nice one. Just use your cell phone. You can do that. You're going to get 29. What do they want us to plug in next? 0.5 is on my list. Okay, so I'm going to cheat. I have a nice little calculator. Let's plug in 0.5. I get 26. So after half a second, it's at 26 feet. Plug in 0.75. I think that's next to my graph. Yep. 21 feet. Plug in 1 second. Ready? Plugging in 1 second is 14 feet. Let's see. Plugging in 1.25. So this is kind of narrowing it down for us. Hopefully you can still see. It's at 5 feet, so we're almost at the ground. Remember, 0 is when it hits the ground. 1.5. Negative 6 feet. All right, there it is. We found our negative, which means it doesn't exist. Let's plot our points. 0, 30. 0.25, 29, so it's barely fallen. And then at 26, so it's falling a little faster now. And then 0.75 is at 21. And then 1 is at 14, so you can see we're starting to fall a lot faster. 1.25 is at 5. And I'm not even going to graph that one because it's negative. Here goes the pebble. Whee! Starts to fall really fast. Somewhere between these two. So I'm just going to write between 1.25 and 1.5 seconds, it hits the ground. All right. Well, I hope you guys enjoyed the video. I know I started going pretty fast there at the end with my calculator, but I hope you enjoyed. If you don't enjoy it, we'll never do it again. And if you do enjoy it, if I have time, I'll try again. Have a great day.